This video is going to be a lesson on how to solve systems of equations using elimination. This is the other useful method besides substitution. Both methods are incredibly important though, so if you haven't seen the other one, please make sure that you get a chance to see the other video on solving systems using substitution. Okay, so let me remind you guys what a system of equation is. A system of equations is when you have more than one variable. What we're dealing with right now is two equations with two unknowns. So here is our system of equations. And this time we're going to solve it using elimination. So, let me write down the steps for how we solve. So step 1, you're going to pick a variable to eliminate. Now, how you pick it is actually going to depend on the problem, but I'm going to give you guys a general strategy once we do a couple of examples. So first you're going to pick a variable to eliminate. Step 2, multiply both sides of each equation by a number such that the coefficients of the variable you want to eliminate are opposites. I know that's a long sentence. Let's read that again. It says multiply both sides of each equation by a number such that the coefficients of the variable you want to eliminate are opposites. So in other words, if you chose to eliminate x in the first step, then that means you're going to multiply both sides of each equation by a number so that the coefficients of x are opposites of each other. Now, what happens when your coefficients are opposites? Well, if you add both equations to each other, the coefficients that are opposites are going to cancel each other out. So the variable gets eliminated. So add the two equations together. So I'm just going to say that this will eliminate the variable. So, step 4, you're going to solve the equation for the remaining variable. Now note, at this point, what might happen is that all your variables might disappear. So let me actually put that in a little star here. If all your variables disappear, then that means we have two cases. We either have a true statement or a false statement. A true statement such as 1 equals 1. If you have a true statement, then your answer is going to be infinitely many solutions. And if it's a false statement, like 0 equals 2, your answer is going to be no solution. So it's either infinitely many solutions or no solution. Now, this doesn't happen very often, so most of the time you will be able to solve the equation for the variable. Step 5, once you get your answer, you're going to substitute the solution into any equation to find the other variable. Okay, so it's a 5-step method, much like our substitution was a 5-step method. So let's solve some systems, do some example problems. We're going to solve the systems using elimination. So step 1, or problem 1 I mean. We're going to solve the system x minus y equals negative 3 and 2x plus y equals 18. So looking at this equation, it says in step 1, pick a variable to eliminate. Notice if we look at the y's here, they are already opposites. Notice I have a negative y and a positive y, so those are already opposites. So actually, step 2 is already done for us. I don't have to multiply the equations by anything because they're already opposites. So I'm on to step 3, add the two equations together. So if I add these two equations together, I get 3x, the negative y and the positive y cancel each other out, and negative 3 plus 18 is 21. Sorry, negative 3 plus 18 is 15. My mistake. Divide both sides by 3. I get x equals 5. Once I get x equals 5, I can plug it into one of the two equations I started out with and find the second one. So maybe I'll go ahead and I'll plug it into the first equation. I get 5 minus y equals negative 3. Subtract 5 from both sides, I get negative y equals negative 8. Divide both sides by negative 1, I get y equals 8. So my solution is x equals 5, y equals 8. Or another way of writing that is 5, 8. Two ways of writing the exact same thing. Sometimes people even just write this. All of these are okay. Alright, so that was an easy one. Let's try making these a little bit harder each time. So we're going to solve the following. Negative 8x plus 5y equals negative 16. And 4x minus 7y equals 8. Now, looking at this problem, we need to pick a variable to eliminate. If I look at the x's, I notice that one of them is an 8, the other is a 4, so it would be really easy to eliminate the x's if I were just to multiply the bottom equation by 2, because that would make them both an 8. Notice if I look at these guys, 5 and 7, these are not easy to eliminate because I'm going to have to multiply both equations by something instead of just one of them. So I'm going to choose to eliminate x. So I'm going to multiply the bottom equation by 2. I end up with 8x minus 14y equals 16. Make sure that you multiply every term. I'm going to go ahead and write down equation 1 up here. Now I add my two equations together. The x's go away. I end up with negative 9y equals 0. Divide both sides by negative 9. I end up with y equals 0. Once I get y, I can plug it into any of the two equations starting out with. So I'm going to go ahead and try putting it in here. I end up with 4x minus 7 times 0 equals 8. Or 4x equals 8, or x equals 2, if I divide both sides by 4. So I end up with x equals 2, y equals 0. Or another way of writing that answer, xy equals 2, 0. That one was a little tougher than the one before because I did have to do some work before actually adding the equations together. Let's try a tougher one. This is problem 3. 5x minus 2y equals negative 6. And 4x plus 5y equals negative 18. Now let's think about which variable I want to eliminate. If I look at the x's, 4 doesn't go into 5. I'm going to have to multiply both numbers. If I look at the y's, neither one goes into the other, so I'm going to have to multiply both numbers there as well. So actually, it doesn't really matter which one I want to eliminate. They're both about equal in difficulty. So I'm going to go ahead and eliminate the y's, since they're already opposite signs. That means I'm going to multiply the top equation by what? Well, I look at 2 and 5, and the lowest common multiple of 2 and 5 is 10. So the top equation I'm going to multiply by 5. I end up with 25x minus 10y equals negative 30. And the bottom equation I'm going to multiply by, since it's a 5, I'm going to multiply it by 2. I end up with 8x plus 10y equals negative 36. Add my two equations together, the y's cancel, I end up with 33x equals negative 66. Divide both sides by 33, I get x equals negative 2. Once I get my x, I plug it into either of the two equations. I'm going to use the first one. 5 times negative 2 minus 2y equals negative 6. I get negative 10 minus 2y equals negative 6. So add 10 to both sides. I get negative 2y equals 4. Divide both sides by negative 2. I get y equals negative 2. And so x and y happen to be the same thing. I get x equals negative 2, y equals negative 2. Let me just write the answer this way this time. By the way, I could have done this problem by eliminating the x's first. Then the LCM would have been 20, right? Between 5 and 4 here. All right, great. We're going to do a couple more examples. This time, let's do one with fractions in it. Okay? Fractions. Yikes, how do we deal with these guys? Let me write down the problem. We have x over 12 minus y over 8 equals 7 over 8. And y equals 2/3 x minus 7. Now, to give you an idea of how you would do a problem like this, first of all, notice that the bottom equation is not in standard form. You should always begin by making sure that x and y are on the same side of the equation. So I'm going to do that by subtracting 2/3 x from both sides. So the bottom equation becomes negative 2/3 x plus y equals negative 7. The top equation is x over 12 minus y over 8 equals 7/8. Now, I don't know about you guys, but looking at all these fractions is making me dizzy. We want to get rid of them if possible, and we can, right? Remember, multiplying the equation by the LCD will always get rid of the fractions. So I'm going to multiply by 24 on the top equation. The bottom equation I'm just going to multiply by 3. What do I end up with? Well, 24 times the first one gives me 24 over 12, which is 2. So 2x. This one gives me 24 over 8, so minus 3y. And this third one, 24 over 8 is 3, times 7 is 21. This bottom one, if I distribute the 3 here, I get negative 6 over 3, which is negative 2x, plus 3y equals negative 21. Now notice that in my two equations, if I add them together, my variable will already be eliminated. So I add my two equations together, the x's go away, but the y's also go away, and guess what? So do the numbers. I actually end up with no variables altogether. So let's refer back to my notes. Notice that I wrote down that If all the variables disappear, we're either left with a true statement or a false statement. This guy is true. This means that I have infinitely many solutions. So yes, this is a special case, but it does happen sometimes, so I want you guys to be aware of this. Let's do another one. Alright, let's go for elimination again, and we're going to eliminate what? The x's or the y's? Which one do we want to go with? Well, let's go with the x's this time. I'm going to multiply the top equation by 3, because that's going to make this coefficient of x a 12, and notice I want it to match the 12 on the bottom, but be a negative of that. So I end up with negative 12x plus 21y equals 39. The bottom one is 12x minus 21y equals negative 5. So if I add my two equations together, the x's go away, the y's go away, I end up with 34 on the right. Notice that all my variables disappeared again, so this is either a true or a false statement. And if you look closely, you notice that this is in fact false. 0 is not equal to 34. So what does it mean when it's false? It means that this system has no solution. And that's how you write your answer. Sometimes people write no solution like this. This means that it's the empty set. Alright, I hope that was useful to you guys, and I'll see you next time.